Good evening, everybody. I'm Tracy with Legacy Woodworking Machinery, and we do this once a month where we have a live online class. In the meantime, between classes, you can come into our website and go to, if you click on the menu bar, go to the CNC workshops, and you can fill out this form right here. And we'll take those and we'll be making videos that answer these questions and address these issues. And then those videos will be released out throughout the month, about every week. And then once a month we'll do something live together, so that get a chance to touch base with everybody and get a chance to get some feedback and see how to be better at what we do and how we can help you out more. Okay. So with that out of the way, tonight's class, I'll click on this right here, is programming the mitered dovetail for the antique reproduction table. Now I have to tell you that this level is advanced. It's not a beginning level programming. And that is because of the software that we're using and how we have to work around some of the shortcomings of the software. You'll see that when we get started right away here. But this is being recorded, so we will post on our website. You'll be able to come back and review it. If you, after the class, and if you watch the video and you still have questions and something's not clear, you can fill out the questionnaire over here, the form, and submit that, and we'll come back and clarify anything that we may not get settled in this class. All right, so I'm going to open up Aspire, because in the last class we actually built this particular leg. John actually originally machined all of these beads here, these stacked beads, using router bit profiles, and then he carved this section right here. He used 3D model and carved it. This is the kind I consider it the old-fashioned way. We don't do this any longer because there's so many better, faster ways to do it than carving. But typically in Aspire, that's what you would normally have done, is raster carve this turning. And so we've gone through that. In the next video, which is this class tonight, after we got the legs, we're going to show, in fact, let me blow this up a little bit. We're going to show you, well, let's go back one. And you see in the bottom of the table, this is kind of chewed up, but this is a dovetail slot. So it has an opening here, kind of like a keyhole, and then a dovetail that slides out. So that means that on the ends of the legs, you have to have the dovetail pins. And they're set at 14 degrees, so it's not level on the top of the leg. So we've got a couple of challenges that we have to address, is how we're going to machine those tenons on a 14-degree angle on the end of the leg. Okay, so that's what we're going to be doing. We, of course, took all these dimensions from the samples that were brought in from Tommy Holmes brought this in, and we're working on all this, putting it all together. It has a base, kind of a shelf, and then it has the legs and it has the tabletop. So we'll kind of finish that off and show how the whole reproduction is created. But tonight we're going to focus specifically on those dovetails. All right. So in the past I've worked with one of the new tools. Well, I don't know how new it is. It's one of the very powerful tools in Aspire or VCarve Pro. So normally under design, we've got all of our CAD tools where we're drawing and designing everything. And then you've got components, you've got sheets, clip art, and layers. And what I'm going to focus on here is the sheets. So if I click on the sheets here, you can see right now I've only got the one sheet active, so that's the leg. Now I do have various layers as well, and I can activate the layers here on the side, or I can do it from this drop down. And so if I want to see the leg details, once you turn the leg, this is what it's all going to look like when it's completely finished. I guess I could have drawn the line across there to finish that off as well. But this, then, if we put dimensions on, gave us all dimensions we needed in order to program. Okay, so the combination between sheets and layers is extremely powerful. So what I'm going to do now is I'm going to turn on my next sheet. And if you look over here in this list, you see I actually number them. One leg, two, the 14 degree. The reason I do that is because I want them on this list to be in the order that I like to work with them. Okay, and so I put the number on there because then it sorts it here. Otherwise, it's going to be the 14 degrees is going to be first, and then the clamp, and then the leg, and then the miter, and then the test. And so I put those numbers. That's just my own preference. All right, so let's go ahead and activate the second sheet. Okay, and here it is. And if I click on it here, or double click on it here, it's going to activate it. Or I can double click over here on the screen and activate it. So this is a 14 degree fixture. Pretty straightforward. So all we do here is that we create a blank a certain size. We draw a line and a line here at 14 degrees. And we'll cut this out. And I V-carved this. In fact, if we go preview all of this real quickly. Let's just preview all toolpaths. Okay. And I believe I left tabs on here because I wanted to make sure it's going to stay together as I work on it. But I'll break those tabs and sand that off, and I'll end up with this fixture right here that we'll use to set the vertical workstation, the y-axis vertical workstation, on that 14 degree angle. So this edge up here goes on the surface of the spoil board or T-slot table or whatever table you have on, vacuum table, whatever it is. And then you set the angle of the vertical fence on this angle here. Okay, because we know those legs have to be at 14 degrees. So I'm not going to go into a lot of detail here because it's pretty straightforward. I just drew a line and drew a second line, 14 degrees, and then I did a dog bone here so that I'd have, this is never going to go into the fixture, but it's just good practice. I won't have a corner here for anything, so if I ever need to put it right up to that corner is not going to interfere with anything. So not necessarily per se in this particular job, but it's something I do a lot. Okay, so here is the thing I want to cover real quickly while we're going through sheets in this particular project. If we look at the leg, that sheet, that job setup is different than the fixture here, obviously. Okay, so you'll notice now if I go back to my design and I click on this job setup right here, it says that my widths and heights and thicknesses are all various. So you can't come in and change this particular sheet or change this sheet from the job setup on the design tab. Okay, so what you have to do, I'll just get out of that real quickly, is you'll go to the sheets and then you'll click on the one that you want to set up, and then down here at the bottom you'll click on edit. And here I can say, well, this one's 14 inches long, it's 9 inches in the Y, it's 3/4 of an inch thick, and I'm going to put my XY data position here in this bottom corner because it's going to sit on the horizontal vertical table when I cut it out, and I put my Z0 position on the machine bed. Okay, I could put it on the top or the bottom. So every sheet can be set up with different material, with a different XY data position, with a different XY, and so on. They can all be set up differently. If we go back, this is going to recalculate when I hit OK here. If we go back to the leg, and we went through this in the original class, and with that selected, now I'm going to click on Edit, and you'll notice that it is 32 inches long. It's 2 inches by 2 inches square, the blank is, and then it's 1 inch thick because our Z0 is on the machine bed, which is actually at the center of the 2 inches. That's why this is only 1 inch. So we're kind of working around the limitations of the software and saying we're not going to do this as a 3D model or as a turning. We're simply going to draw it as a 2D. We're going to let the software turn this like a lathe, and we're going to machine all this with router bits. So I don't need to create a model at all. I can do all of this in CCAMPro, for example. Okay, so you notice the XY data position has an offset of a -1 inch, which pushes the 0 of the y-axis into the center of the parts, 2 inches wide, but it's here in the center. So now my Z and my Y are in the exact center of the part, and the X is at this end. Okay, so that's how we're going to work with sheets. So I like to, as I go through this, you'll notice that I've got all these other sheets on now, and I can turn each one off. The third one is the clamp fixture. Okay, so we're going to go through this. I'm not going to bother with the template, the 14 degree fixture, because that's too simple. But on this one, I'll show you what I did was I downloaded from our website, and if you go into the customer support files, then you're going to have downloads for team viewer display table. You're going to have the vertical table. Oh, here it is. I had to look and find it. The Maverick Vertical Workstation DXF file. So I downloaded that file. So then I could take that and bring it in. So if it's on a layer, so if I turn that layer on, it's called the vertical fence. That's what it looked like, is it has this hole pattern. Now I wanted that hole pattern and everything so I would know how to build this fixture. So I'm going to drill holes in the fixture so they line up with these holes here. Now it's pretty simple. These are 2 inches apart, the spacing between each hole, and these are all threaded 1/4-20. So I'm going to turn that back off again because it's actually kind of confusing to begin with. But you can see the hole between here and here is 2 inches, and the hole between here and here is 4 inches. And this is wide enough that it fits right on the vertical fence. Okay, so it's as wide as the fence, but it's not going to be nearly that big. I actually only cut one part, so if I go in and say let's go to the 3D view and preview this guy. Let's close all that. Let's go back to here. Okay, now we're going to go into preview. And what I did here is the leg I know is 1 3/4 of an inch in diameter. So if I have a router bit, a core box is that big, I could just use that core box bit and cut that, and I cut it 1/4 inch deep. Okay, pretty easy. But I didn't have 1 3/4 core box. I only had 1.5 inches or a 2. So I said, okay, then I'm not going to use that. Let's undo that. And what I ended up doing was I said, okay, I'm going to create a 3D model. Okay, so over here you can see we used this drawing right here to model these 2 channels, and it's based on 1 3/4 inch diameter. So if we go back to the 3D view, let's close out of this real quickly. Now you can see if in the 3D view, that is the model based on this vector right here. It's going to model this whole thing, and then we drew these vectors here, these boxes, closed vectors, around the model, so that when we went into the 3D finish, which is the model, we said only machine inside the selected vectors. And so it didn't machine all the flats between, it only machined, it carves this section right here. We used a 1 inch diameter core box bit, you can see right here. So it's pretty fast. Now we ended up with a 2.5% or a 25,000 step over with a 1 inch cutter, and that'll give us a nice smooth finish. Okay, and then you can see here I'm going to create 2 of these, and so let's go in and actually model this real quickly so you can see this. What I'm going to do is we're going to carve it, then we're going to drill the holes next, and I just used a 1/4 inch drill bit to drill the holes. And this is actually 2 parts, but I wanted to machine it all as one. This one right here, if I preview it, just shows you, I'm going to take this to a table saw afterwards and just cut that. Okay, I could machine it in half, but then you're getting pretty small parts and you got to clamp everything and so on. So I said, you know what, I'm just going to cut the whole thing, and then I'll go to my table saw and just rip that. These are 4 inches wide, each one of those. So I create 2 of them. So when I save out the code, I do not use this one, and I don't use the channel either. I'm only going to use this one and this one when I save the code out. Okay, and so then I have, let's go back to the 2D view. I'll have one part that will bolt against the vertical fence, and you know what, to be honest with you, this is kind of deceiving because these are really going to turn 90 degrees like this, because the vertical fence goes along the y-axis this way. So this one bolts to the fence. We just take a cap screw and we go all the way through, and bolt both of these into the machined aluminum fence, vertical fence, and there's one on each side. And then the part will come up through that to clamp in this groove right here. Okay, any questions so far? Okay, that's the easy part. This is really simple. This is fairly simple. All right. Next, we're going to skip the test. We're going to do that last. We're going to focus next on the actual mitered dovetail. And this is where it gets really, really tricky. Okay. Let's... and you might be asking, well, why is it in this order? If you're going to work on this one next, why does it go the leg, this, and this, and this, and this? Well, you can order them over here any way that you want. And so I use the number to order those, list them in the order that I want. But the way they're put on the screen over here is by the x-axis. So your longest x-axis is going to go first, the second longest, second, then third. And sometimes they'll stack clear out here. Other times they'll start stacking in a second row. I don't understand exactly why, to be honest with you, but that's what they do. So it's going to be arbitrary, but it's going to go by length. So it goes 1, 2, 3, and then it starts up here, the next one, and the last one. So we're going to just double click on this one right here, and we're going to start showing you how to develop this. This was fun. Okay. Okay, so what we're seeing here is a couple of things. This is a router bit here. This is I get this router bit from Magnate. And by the way, I do have the router bits on here. I turned that layer off. So I just grabbed this 14 degree 3/4 inch diameter. I use that bit right there. Bit number S019. That's what's going on here.
415.
Oh, it's 405. And it's interesting. It's as I zoomed in and out, it actually changes it, makes it look different. That's bizarre. Okay, 405 has the cutter number there. Never seen that before. All right, so I'm going to turn that off because it just gets in the way. All right, so what I wanted was the dovetail slot is going to be cut with that same router bit. So it's going to be 3/4 of an inch at the bottom, and I wanted to go a 1/2 inch deep. So I put one here, and then I said, okay, so I want this tenon to be 3/4 of an inch wide. So that length of that is 3/4. You can see that right down here. And then I copied the bit over here as well. So what I'm going to do is I'm going to machine all of this on the top of the leg, and it's going to leave this dovetail pin standing up. All right, so that's the concept of the size. Now the question, what are all these lines and these other things? And I'm going to show you how we do this. I'm going to go to a layer now, and I'm going to use, I created one called the leg stage 1. Okay, so this is the leg's much longer. Of course, it's like 23 inches long, or something, whatever it was, 32 inches long, I think, or something like that. But I only did it so long because I just needed to work on the top section. But the angle of this is set at 14 degrees. Okay, so if it was standing straight up, I would rotate it. I would say the angle is going to be either 14 if it's standing up, or if it's laying down, I'm going to rotate it up. 76, 86, 90. Yeah, 90. So at 76, we'll put that at a 14 degree angle. Okay, so that's what I've done in the stage 1. I just put that in here, and then you've got some guides, and we drag the guides from the side over here, right? And so we said, okay, this edge is right there at that point, and this edge is right here along the edge. Now this blank is not really 1 inch and 3/4 square, and the reason it's not is because if you come in here and we're gonna machine this so it's flat across the bottom like this, right? And when you do that, it's now wider than the inch, and along the x-axis, left to right, it's wider than the 1 inch and 3/4. The width is still the 1 inch and 3/4, but it gets wider this way. So we make this part a little bit longer. Now, what's going to happen next? We're going to put that in here. We're going to set it up. And the very first thing we're going to do is going to machine that top off on that angle. We're going to surface plane it. So I'm going to turn on my stage 2 and turn off my stage 1. And we have just machined that off. Well, let's turn stage 1 back on for a second so you can see this how it's going. So it starts off square at the ends. We put it in the machine at 14 degrees, set that up with the fixture, and then we machine this off. And that's part of this up here. I'll cover that in a second. Then, if I turn off the stage 1, and we have that part sitting there, the next thing to do is to cut the dovetail, and that's stage 3. Okay, so we use this dovetail bit right here, and we go around it like that to relieve that, and we get that dovetail pin on top of the part at a 14-degree angle. Okay, so pretty simple. The concept is really simple. All you're doing is you're programming everything, but because you're tilted on 14 degrees, you can't model. You can't model a dovetail bit, first of all, and you can't model this at that angle. So we have to kind of imagine and think it through very carefully is what's going to happen. So I like to draw it up like this because then I can see what we're trying to accomplish. Okay, so let's turn on all 3 stages so you can kind of see everything here. So this, you see this circle right here? Okay. This is, if actually click over here on surfacing, you can see that it's using that circle right there to surface plane the material. So what we did is we said, okay, here's the actual edge of it right here, and you can actually see if I put a guide right there. I'm going to turn that off for a second. Okay, I'm actually need to do all of that, and so I could create a circle that's exactly well, it's not really 1 3/4 inches. You could do 1 3/4 inches and it'd be fine, because we do an offset from that 1 3/4 inches to create this one right here, and we go out 0.3 inches. So what that's going to do is it's going to take a 1/2 inch router bit, and it's going to cut around here, because if you go into the surfacing, or you're using the pocketing here, we are saying we're going to do the profile pass first, and we're going to do a conventional mill, and then we're going to raster. What that means is it's going to cut around the outside. And so if I were to, let's close that real quickly, and if I'm to draw a 1/2 inch diameter bit in here, okay, and I'm just going to put it right there for a second. And we'll take that bit and let's put it to this size right there. You can see it's going to cut all the way around, and it's going, because this part is round, not square. We've already turned it round when we made the leg. So I can't show that here. It has to be a rectangular part. So, but the part's going to be round. That's going to cut around, and it's going to climb mill all the way around that edge. And then it's going to surface everything, you can see. So we could actually pay no attention to those lines for the dovetail. It's just going to surface that clear off. Okay, so let's go into our preview here. Let's turn that off for a second. And let's now, and again, this that's the top. We want the front like so. Well, I'm going to tilt it up just a little bit so you can kind of see. So it's really sitting on an angle like this, but you can't model that angle, that part sitting on the angle. So you just have to imagine. Okay, so when we looked at this, let's turn our dimensions on. And we said we're going to set our Z0 right here at this top corner. Okay? Now our x-axis is actually going to be set here at this corner, and our y is actually going to be set on this corner. So it's really kind of right here in this corner. You can see the XY datum positions right here. But there's nothing there to actually put the laser on. So we set the X on this edge. We set the Y on this edge, and that'll put X and Y at this corner. And then we set the Z0 on top, which is at this point right here. So we need to surface plane all this down 0.4234. Or if we wanted to round that to 3 positions, 0.424. So now if I open this up, you can see cut depth 0.424. From here, it's going to surface. Now down here, it's not going to cut anything because there's no wood there, but it'll machine this all off flat. And we're using the 1/2 inch end mill. Okay, and we're cutting 150 inches a minute. Now if we're going to ramp into here, we would set that to the same. But if we're going to plunge into it, then it's going to be 30. Okay, and we ramp the plunge moves. Okay, so in that case, I'm going to come in here and I'm going to change that to 150 so that it ramps the same speed that it cuts around. Some people do half the speed, so they put that at 75. It's a preference. If you do 30, it's going to ramp really slowly down, and then it's going to take off real fast, and I don't like that. So I like it to ramp and just continues to cut all at the same speed. That's why I set it to the same speed. And then we check this ramp, the plunge, and the distance is going to be over 0.7 inches. Okay, so that's cool. And again, we're going to cut around the outside first, which is going to climb mill the round all the way around, and then it's going to cut across there. So let's calculate that, and then we'll preview it. So imagine this on this. I'm going to zoom in. It's sitting on an angle. It's not going to be flat like this. It's going to be crossed here like this, but it'll. Okay, I have this on a high resolution. I apologize. It's going to take a while. In fact, I'm too impatient. I'm going to hit this X down here to stop it. I'm going to come up to my toolpath, previous simulation. I'm going to put it down here to high, and then we'll come back and preview it. That's interesting. It does the zigzag. Okay, so it went all the way around, and remember that's climb milling around that round end. And then it's, so these corners aren't going to be here. And then after that's done, it climb mills all the way around here, and then it does a raster cut back and forth to remove all that material. Okay? And again, this is what's difficult. We just have to know that the part's on an angle, so that's flat across like that, even though in the 3D view it looks like it's flat here with corners on it. It's not real. Okay? Now the dovetail relief. This gets a little tricky. Okay? So what we're going to do is okay. What we're going to do now, this vector here, you can see that it goes all the way around and then it cuts around like this. Now the reason we do that is we're going to use a 1/2 inch diameter cutter again. And if you notice, if I come out here to this, I have some clearance in here. So it's going to cut around here and follow that. And it's going to machine all of this out, leaving all of this material here for the dovetail. So the part's still on the angle, and we need to cut that down. And we're going to go down the 0.5, but keep in mind that the original Z0 was here on the very top. So we have to go down 0.424 plus 0.5 in order to machine the second layer. Okay? So let's double click on the dovetail, and you can see we're starting at 424 because there's no material there. And then we're going a 1/2 inch deep. And then this is a 2D toolpath, and so it's just going to, it'll actually machine all of the material to clear that all off. I'm going to verify that real quickly just to make sure I'm not lying to you. If I take this 1/2 inch cutter, oops, don't do that. Let's take this 1/2 inch cutter, and I put it, grab that quadrant, put it right there, and then I copy that. And I could have just, even better than copying it like that, let's just do a mirror. We'll just flip it to the bottom. You can see that it will clear all the material. It'll overlap slightly because this one here is only going to go to right there. Okay? So we didn't need to do a pocket here. We could just do a profile toolpath, and it will machine that all out. That's why we use 2D profile, because it's going to remove enough. So we created this one big enough that it would, of course, remove all the material around with the 1/2" cutter and then leave this dovetail portion right here. If I take that bit and I just kind of jog it over here, and I can say, okay, where's it going to end up? Okay, you can see that if I come in here, I'm just going to move over till it's about at that edge and about at that edge there. You can see that, well, if we zoom in far enough, there's actually a little bit of material left here, but we don't care. It's going to come in here and then cut around. It's actually going to be going this way, climbing, and go around it. So it's climbing at the outside. No, it's going to go that way. That's right. I'm sorry. And then it's going to leave just a little tiny bit of material here, but that's okay, because now when we take the dovetail bit and we cut this, it's going to remove that little bit of waste right there. That's all going to be gone. So this is the 3-step process. The first one is to surface plane it on the angle. The second is to remove all the material except for this plug right here for the dovetail. And so let's go ahead and calculate that. Parameters, what did I done? Okay, let's go ahead and preview. Okay, so that surface, here's cut our dovetail. Now you got to keep in mind, this material is not and it's there, but it's said this is all on an angle, right? So there it has cut all the way around and just left that section on top, and it's on this angle, so it's right here. So it's again, if I go back to tearing off stage 1, it's cut that on stage 2. So here's the top view and the side view. Cuts around like that. Okay, then the last one is to cut the actual dovetail. And if I click on that, you can see that it's using this profile here. So we make sure that it goes beyond the surface of the wood, because it's going to plunge down in, and we're going to start right here. It's going to plunge in, and then it's going to cut around and back out. Okay, so this we use as an open vector so that we can do a profile toolpath. So let's double click on this. I'm going to click on that, double click on this, and it's a 2D profile, and it's that depth. Okay, and so it's going to I got my dovetail bit. Now I'm cutting on the left side, so here's the starting point. That means the bit is sitting over here. The diameter of the bit is actually 3/4 of an inch. Okay, but the top of it is a 1/2 inch. It's here, this section here is it's 0.5007, so 0.7 of a thousandth of an inch. So effectively it's a 1/2 inch. So if we say use this 3/4 inch dovetail, the wide section right here, and follow that line, the outside of that line, it'll go around, and it will leave this portion of it up here as the top. This section up here is now this section here. And this right here is the bottom right here in this corner. Okay? And again, you can't model this. So when we come in here to say, okay, let's preview this, that's all it shows you. Okay? It doesn't show you that it's actually cutting the one section wider than the other section. Okay, so that is the concept for machining the actual programming, rather. You know what? I actually deleted a toolpath here. I don't know how I did that, talking and working at the same time, because we should have this toolpath here to remove all that material before we cut the dovetail. So surfacing is just cutting right flat. Okay, so here's what I'm going to do. I am going to close this, and I'm not going to save it, and I'm going to open it back up, because I should have that. If not, we'll program it real quickly. But okay, let's go to this one, and let's kick over to our toolpath. Oh yeah, so the dovetail relief, I somehow deleted it. Okay, so let me step through the model one more time so you can see it all. Let's go into the 3D toolpath right here, Here's the surface. And again, it looks like it's cutting flat, but it's only cutting on this shoulder over here. And these corners do not exist because it's round. It's slightly elliptical because remember it's slightly wider along the x-axis than the y-axis. But this will work. Okay. Probably should have set that for the fastest and not deal with it. So this is how it's surfacing everything off. Then the next one we're going to preview is we're going to say, okay, now cut all the relief for the dovetail. And it's going to climb around and then cut the relief for the dovetail. Okay?
Tracy?
Let me finish this last one, then I'll answer your question. Then the dovetail is going to cut that. It looks like smaller because that's actually the bottom cut, but the top will be wider. You just can't model that. And that's all on an angle. Okay. I'm sorry. You had a question?
Just to be clear, how did you compute the width of that slot?
Okay. When you say that slot,
Well, your dovetail is a 3/4 inch dovetail, but how did you compute that width of that vector you have highlighted?
okay. So we know that this section right here is, and I can look down here at the bottom, is 0.75. And that's what we want the tenon on the top of this. That's this right here. Is the width of this is 0.75. Okay, so if I was to measure that right here, I hope I'm following your question, but I'll go through it. If we measure from here to here, that is in the y-axis 0.75. Okay, so that's what we want on the top edge of the dovetail pin, right? But we're going to cut. We drew this vector here for the bottom, which is this corner right here. So if I was to measure, let's just measure right here. Okay, that along the x is 0.5007. So if we were to measure, again, the width of this in the y is 0.505. That's interesting. So that's saying it's 5 thousandths wider. Okay. Now, and technically it should have been exactly 5. I must have messed up when I was drawing it. Okay. So it should be 0.5 inches because that is, again, the width of this section right here. So by drawing that line, we can tell the router bit, the dovetail, to cut on the outside. It says it's 3/4 of an inch. So this, if this is the bit here, I'm saying take that bit and on that corner right there. In fact, let me do this. I'm going to take this. I'm going to move it over, and I'm going to put it right there. Okay. So the outside of the bit is going to follow this vector all the way around like this, and it will leave this vector at the top. So it's going to be this wide at the top and this wide at the bottom. So I made this one a 1/2 inch wide to equal this, and then I made this one 3/4 of an inch wide from here to here. Okay, and this one again I completed with the circle, so it would do a profile toolpath and remove all that material. Then this is a profile toolpath just to cut around that. Okay, and again, if I go into that dovetail bit, cut the dovetail, you'll notice I'm cutting to the left, and the starting point is right there, and it's cutting to the left, and it says it's climb milling, so that means it will cut like this all the way around. Does that answer your question?
Yes, it does. Thank you.
Okay, great. All right.
Tracy, I'm guessing you left 5 thousandths for glue tolerance.
You know, possible, but that brings up a really great point. I'm glad you mentioned that because, you know, if I had made this if I designed it so I cut right in the center of the router bit and it went around, then you cannot set an allowance. For example, if I click on here, I can't do an allowance. But by clicking on the left, I can come in and give an allowance. So what I would do is I'd turn a sample, you know, scrap piece, and I would cut it with this. And then you play with this value right here to make that dovetail a little narrower, or, you know, for glue, or make it a little bit larger if you need to tighten it up at all. Okay? So and that brings us to the last thing. So by cutting not on the center of the bit, but on the outside, that's why we did that, we can use the allowance to adjust that dovetail pin. that brings us to the very last one, which is our little test cut. This isn't the actual tabletop, but we wanted to test the bit. So here, and I'm not even sure, to be honest with you. Let's go into here and let's model this. Right, so here's the pocket relief. Okay, that is with a 1/4" end mill, and then the dovetail slot is just a dovetail bit. So this is going to not simulate it exactly. You see it's 3/4 of an inch wide here now. In reality, it's only going to be a 1/2 inch wide here at the top, but it will be 3/4 of an inch wide here at the bottom. Okay, you just can't model this in Aspire, so we have to imagine it and kind of think it through carefully. Okay, so what we do here is we say this slot here is in the Y, it's 0.537, so a little bit wider than the that's actually a little bit less, isn't it? Let me do one thing. Leg dovetail. Okay, that is the actual leg right there. Yeah, and the height is 0.7503. Okay, so we made this just slightly wider. You can see it's just slightly wider than that to give us a little tolerance. And then we cut this, so this section here is the 1/2 inch wide. If I were to measure this section in the y-axis, it's 0.5. Okay, so we would cut this. I would probably cut this because we're going to use this vector in the center to just cut in with the dovetail bit. It's going to be a fixed width. I can't adjust that, and that's why I cut this first, and then I would cut the dovetail pin. So we cut this sample first, and then we adjust the dovetail pin on top of the leg until it fits with the glue space we need and everything. Okay, so this we just made it so that this cuts it wide enough to form that, and it's long enough that the part fits in here, and when it slides forward, it'll fit all the way up in here. So this, when it slides forward, for example, is just going to move up here until it goes right up like that, and it'll be inside the dovetail. And then to get it out, you're going to back it out here, and then of course you can lift it out. Okay, so this part here is pretty simple. It's just a pocket, and we go a 1/2 inch deep. This one right here is a little tricky, because if I have just a single vector that goes from here to here, and I program that toolpath, it'll plunge in here, it'll cut to here, and it'll lift out. And it'll cut a great big hole right here in the end of my dovetail slot, which we don't want, right? So if I go into node editing, and I grab this node and I move it, you can see it actually goes down and back. So when you draw this, it's easiest to draw it down here the length you want, and then draw a vector that returns, and then you can grab this node and just move it till it sits on top of that node. Okay, so now this is a vector that goes down and back, so your toolpath will go down, back, and then lift out. Okay, so you don't blow a hole in that section right there. Okay, so this is actually what I would do before I cut the dovetail, because I want to have a test part to, if I need to cut an allowance or change the allowance offset for the dovetail pin to fit in there, I mess with that. And I do that all in, sample with my prototypes. Once I got everything all dialed in, I put my real parts in and cut it and fit it together, glue it up. Okay, so that's, I know there's a lot of information there. You break it down step by step. It's not that bad. It's just that this one's a little bit hard to get your head around because everything's on the angle. And so that's why I create these. I got to get out of this right here. I'm going to double click on this particular sheet. Come on, give me the sheet. What's going on?
You're in node editing.
Oh, is that what it is? Get out of node editing. All right, let's click here. Oh, yeah, thank you. Very, very good. And so the trick here is to set up, the leg underneath you, looking from the front of the machine along the y-axis to see how it's going to cut there and then cut that last part. And then translate that all up to, I use these guides to translate these all up to it's all perfect. And I say okay, but I'm taking credit that I don't really deserve. I actually designed all this up, and then I had some other stuff I had to get finished. So I said, Chris, finish this right here. Now, Chris, if many of you have worked with Chris and know Chris, he is an incredible programmer. And so he programmed did all the finished programming for me. So I say, yeah, I did it. In reality, I had it kind of all drawn up, just threw it over to Chris and said, finish this for me. So he's the one that did the final cuts.
Tracy, can you mill that dovetail slot with a smaller, say you don't have a 3/4 inch dovetail bit?
Uh-huh.
You do it with a smaller one at proper angle?
You can. So it's got to be, in this case, it's a 14-degree bit is the bit that I chose. So you could use a smaller, but it had to be 14 degrees, unless you change everything to 7 degrees or whatever dovetail you use. And I did everything with 14 because I like the 7 is, less angle. I like the 14. It's really positive. So it's just what I prefer. And that's what I programmed this all up in. But if I had a 14-degree smaller bit, I would have to not just cut straight in like this. I'd have to go in and around and back out. So I would be machining kind of like we did the outside of this one here. We cut around that. You would do the same thing in here. So I'd have to cut one that goes down here, around, and back out and cut it out. So that's possible to create that type of tool path, with a smaller cutter if you want. Does that answer your question?
That was really my question, yes.
Okay, perfect.
When you cut your test pieces, do you use the same species of wood
I would.
as the final product?
Yes, I would definitely do it. And then this particular, because this is a reproduction of an antique piece which was done in oak. And so I would cut all these samples in oak. You could probably get away with a similar species, that's kind of the same. But, the way that the router bit, as it machines, it climbs running away from the edge, and it undercuts pulling into the edge. And it pulls material out of the edge of the material. It affects that as well. So the more dense the wood, the greater the effect. Now, it might be only 1/1000th of an inch or 2/1000ths of an inch. So it may not make a difference, but I would say best practice, do it out of the same species. Then there's not a question. You don't think you got it all done and then cut it and go put it together and say, oh, I got too much slop, or I got to sand that dovetail pin to get it to fit.
It seems to me that this approach to fastening legs to an underside of a tabletop is somewhat unique. What are the pros and cons? If you built a table, would you recommend this approach, or would you recommend a different approach?
That's a great question, because I have never seen this before. When Tommy brought this in to us and showed us this, it was like, seriously, that's how you attach the legs? Because usually you'd put a round tenon or something going up in here, or you'd put a stretcher across here and attach the stretcher to the tabletop and tie all the legs together here. I kind of like this. If you look at some of the pictures, though, it is antique. It is well worn. It's beat up. So, was this a good long-term solution? I don't know. I just don't know. If anybody's got any experience doing this, I'd love to hear it. But I thought it was just a very unique, awesome way to do it. So we were all on board. I said, I'm going to reproduce this because it's not my favorite table, to be honest with you. It's a family heirloom for Tommy. So there's members of the family that want a copy. And so he wants to build this. So I said, well, dang, let's do it. It's good. So, is there a better way? The thing that's interesting that I found on this, I would have thought opposite, differently. Oops, I think I went past it. Let's go back. Is that, oh yeah, right here. See, his slots go here. So when you put the legs in the center, you pull them out. Now, when you put the shelf down below, you're going to secure that, and that's going to lock the legs together at that point. So when the pressure goes down on the tabletop, is it going to push the legs out, or is it going to push the legs in? And that I don't know. I've been going through this and saying, oh, should the slot have been out here on the outside and pushed it in? So it seems like, to me, if the table's like this and you put pressure down, it seems like it would try to push it in this way. that's my thought, but I don't, I haven't tested the theory, so this might be the right way to do it. Some of these builders that build these pieces were a lot smarter than I am, so I have to kind of say, well, if this is the way they did it, let's try it.
Yeah, it's unique. I've not seen this before, and I've seen a lot of old tables.
Yeah, I've never seen anything like this. I think it's awesome.
The pro for this is that it's knockdown if it's all dry.
Yeah. Yeah, absolutely. In fact, you could get really tricky. So when these legs are in here and they're of course they're running up on these angles, you could put a spacer between it. You put them in because they push out like that. You could put a spacer along here underneath the table so it wouldn't be seen. You have that lip right here, so it'd be hidden underneath there. Just attach it right here and maybe put a screw into it or something, and that would push those legs out and secure it. And then if you wouldn't have to glue it. You just pull that out, and you could actually machine a little plate that does all four, and you just push that down in and attach it with the screw in the center, and that would be pushing those out. And if you ever want to take it apart, you just pull that screw, that thing pops out, and the legs just all come out of there. You wouldn't glue it. I mean, a lot of possibilities. It's fascinating. I was fascinated when I found this. I thought it was awesome.
My wonder is, what part of the world did the antique table come from? Because that would help you with the design.
Yeah, I would. I think Tommy's from. Cindy, Tommy's from Texas.
He lives in Texas.
Tommy lives in Texas, so his family's probably from Texas. So I don't know if that's where it was purchased originally, but that's where his family's from. So I don't know if his parents or grandparents originally were from there, but I don't know how old the table is either. I just know he said it's a
Tracy, can you hear me?
Yeah.
I think you'll find this is not common, but this was used back in the early 1900s. The only problem is it's very time intensive to machine those details, but that's what carpenters did back then.
Yeah. But on the CNC, this is actually pretty slick, pretty easy. It was kind of, when I saw it, I was very excited because I thought, who cuts an angled dovetail on top of a leg? But there's an easy solution, vertical fence that's adjustable, boom, you're done. So,
Tracy, I believe this table was built around the turn of the century. And of course, it was all done by hand.
Is this Tommy?
This Tommy, yes, sir.
Hey, Tommy, how are you?
Doing good.
I'm sorry. I should have asked you to answer all these questions because I'm just shooting my mouth
Well,
off.
I was actually listening to you there. First time I took this table apart because I had to repair the bottom shelf in it.
Uh-huh.
It had got damaged and so forth, and so I actually repaired it for my niece because she'd got it from her dad, which was my brother. And the legs was not glued at that time. So when I put it back together, we put just a little glue on the legs, and then put it back together, refinished it, and then she carried the table to California, of course, in a truck, U-Haul truck.
Mm-hmm.
When she gave the table, well, after she passed away, and I got it from her daughter, which was my great niece, they gave it back to me, and so I had to take it apart again. I had trouble getting them legs out. They was glued. Well, when I took it together the first time to repair that shelf, to actually build another one, they wasn't glued.
So the dovetail pin secured it, and then the shelf at the bottom just held the
shelf
spacing.
at the bottom would keep them in there. Now, what you would one thing about gluing them is that shelf has got to be in the right place because the table may not be level when you put it back together.
Right.
Now, there's also this slot that you're putting the dovetail back in that you just designed, be the last two pat you done.
Mm-hmm.
You could drill a round hole the size of the leg, just a little bigger. And some of them old tables were built like that. Instead of that slot going back, it was strictly just a hole the size of the leg, a little bigger,
Mm-hmm.
and then it slid in there.
So it just fit in a pocket.
Yeah, you could just put a round hole there, and not do that there. That was particular the way these people that done it. if you measure the original legs here, which was all done by hand, some of the dovetails are a little wider, so you need to try to find the one it was actually come out of. You see,
Yeah, they cut independently. Yeah.
but that's an interesting project. I can say that's pretty complicated on the programming.
Well, Tommy, I'm gonna give you all this programming so you can do this. But I think it's an awesome project, and I'd love to get your feedback once you do this. How it turns out. So. Okay,
So is it fair to say that those internal dovetails on the underside of the tabletop itself were cut with an electric router? Or is there a way that a craftsman from 1750 or 1800 can cut internal dovetails with a hand plane, a router type plane that's cut with the proper cut angled cutter?
I don't know. It could be chiseled, but if you chisel, you can't do around this inside unless you had a rounded chisel. So I just don't know. 1900s, early 1900s, I'm going to guess it's all done by hand. The originals would be my guess.
I wondered that myself, and I've looked at that, and it's I think it was done by hand.
I think so too. Here's what I'm going to do. Again, this is recorded, so I will post it. And if you have any questions, then I want you to go to the CNC workshop and just put it into the form here and submit that. And I'll make sure that those will not be done in class. They'll be done on video and posted in answer to this question, this project. All right. And then if you have any other questions, please submit, and we'll see if we can get you covered.
Check out Legacy's product line and see how to use Legacy CNC to conquer woodworking's most difficult and profitable disciplines by visiting our website at lwmcnc.com. If you have additional questions, call Legacy at 801-491-0010. To watch more problem-solving videos that focus on turning, sheet processing, joinery, molding, 3D carving, wrapped carving, inlay, and more, click right over there. Press the like, subscribe, and bell icon to receive notifications when new videos are released. As always, thanks for watching. And remember, Legacy solves more woodworking problems than any other CNC manufacturer in the industry.